Since question 11 and 12 are already answered, now let's find the answer to question 13. Find the coefficient of dynamic friction between the crate and the floor. So we go for collaboratory. We have question 11 answered. We have question 12 answered and fixed. And now let's go for 2.2, question 13. Let's copy the information again from question 11 and see what we can use for question 13 here. So, question 13 is find the coefficient of dynamic friction. And that's a term that we can find in the formula booklet as well. Here we are. And if we keep it like this, given values, let's have a look in our formula booklet. Here we are. Here we have our forces, and we talk about dynamic friction. Here's the dynamic friction coefficient. Friction force we calculate in question 12. So we can type this one in, and we have to find R, and then we have it. Okay, so let's go for given values. We have the weight given, explicit. We don't need the initial velocity. We can already say what formula we need. So we need force equals mass times acceleration. That's from the form booklet. That's fine. No, that's the wrong one. Force, friction force equals mu slash mu underline dynamic friction, because it states dynamic friction times capital R. So this would be, after it's connected and allocated, will tell us how this one looks like. And we can use the acceleration from question 11 that I put in 12 already. Here we are. Let's copy this one, since we need it for 13 as well. Final velocity, we don't need. Distance, we don't need. Well, and the crate is on the floor, so we can say the reactive force or normal force equals the weight. And that's weight is on the floor. Horizontal, then we can say it's implicit, so we know how big these values are. Force formula is here. Now let's look for the solution. And add some code down here. Oh, mistake. This one is a code block. Of course, that's why it's not rendering. So let's add a text block and put this one into a text block. And now it makes sense and looks how it should look like. And delete this one and delete this entire block. And now let's enter the values correctly. So W equals 25. Newton, and we know the reactive force equals the weight. Force equals Newton's third law, equal and opposite, equals the weight, since weight is the force, FF, and this one is calculated in question 12. 6.8 is the rounded one. Yeah, but more precise. 6.796. Let's take the more precise. 6.796. 6.796, and round the end. Friction force in Newton, calculated in question 12. Make it a dot, and let's calculate. F. No, let's go for the solution. Arrange the formula. That's what you have to do again. So, we don't need these values. U dynamic friction equals the fraction of the friction force divided by the normal force. Here we are. So up here we don't need the acceleration, we need the friction force. So friction equals 6.796 Newton. That's friction force implicit from question 12. Here we are. And move this a little further to the right. This one to the left. Okay. Done. Formula, rearrange formula. Copy the question for the answer. The answer will be in Newton. Has no unit because you're looking for coefficient of dynamic friction. Let's see what the value is. To use our rearrange formula, let's call it mu dynamic, and it should be F friction, not F friction, divided by R. And then format dynamic friction, and let's copy this text again. This, get a placeholder and the unit, and calculate. 0.2718, so down to two significant figures, we add dot 2f. Dot 2f, try again, 0.27 Newton. Here we are. Put in here, 0.27 Newton. And put in here as well. Equals 0.27 Newton. And we have question 30 answered as well.